today once more to our YouTube channel. Today we're going to have a physics content. Our topic on the board today is going to be on moment of a force. So if you're not subscribed to the channel, you subscribe by tapping on the subscription icon or bell under the profile picture. You subscribe by tapping on the bell on the profile picture and get subscribed to be seeing more of our videos. So today we're going to look at moment of a force, a key aspect of mechanics in physics. So, for instance, to this force required moment, we have to take a description first. Assuming that we have a meter rule or a piece of rod labeled uniform body AB, and then we have a knife edge or a support at the part of it, let's say at the region between A and B, that is the knife edge, and then we place a mass here. So before we go on, let's assume that this body AB is a uniform body, and in physics, a uniform body should balance at the center of gravity. So if AB has a length of 70 cm and is a uniform body, that means this point should be 35 cm. That's the balance point. What it means is that when we place a knife edge here, the object becomes balanced. It not move to any side. So let's assume that I put a mass here, a mass of 20 grams here. So that mass is the force acting in this direction. So the moment of this force now, of 20 gram force, will now be equal to the force acting down here, multiplied by the distance from this force to the pivot. Let's call the distance S. So moment of the force, that is 20 gram, becomes the 20 gram force times the distance x measured to the pivot. So in physics, how do we define moment? We say that moment of a force is the product of the force and the perpendicular distance from the line of action of the force to the pivot. So let us repeat our illustration. Assume that AB is a uniform rod of length 70 cm, and every uniform object will rest or will come to rest, that's equilibrium, when it is supported at the midpoint. So the midpoint of 70 is 35, that's half of 70. So if I put a pivot or a knife edge here, this object AB will come to rest. So will not then go to any side, either A or B. Now let's assume that we put a force down here or a load here. The distance between this force and the center of gravity, let's call that distance y. So moment of this force about this point will now become the product of the force F multiplied by the y. That is force times y. That gives you Fy. So moment of a force is defined as the product of the force and the perpendicular distance from the line of action of the force to the pivot. So if you apply this force acting down here, the distance measured at 90 degrees to the point where the pivot is, we now have the moment of this force around this pivot. So in physics, we also say that moment in physics is also defined as the turning effect of force. The turning effect of force. So in mechanics, moment can also be said to be the turning effect of force. For instance, when somebody opens a tap, so the same amount of force that applies to open it is also the amount of force that applies to close it. When I open the door by touching the handle of the door, the force I apply a force on the handle of the door, and then the door movement has a turning effect on its hinges. So moment can be defined also as the turning effect of force, or force times regular distance to the point of pivot. So that's how we define moment in physics. Now, moment is a derived quantity in physics. It's a derived quantity in physics. And then the SI unit of moment is, since moment is force and distance, force is Newton, distance is meters. So the SI unit of moment is Newton meter. So moment is a derived quantity as well as a vector quantity. So that is moment, or the introductory aspect of this topic, moment of a force, which is force times regular distance, or the turning effect of force. So now we're looking at the principle of moment. The principle of moment. It says that for a body to be at equilibrium, under the action of a system of forces, then the total clockwise moment must be equal to the total anti-clockwise moment. So for a body to be at equilibrium under the action of the system of forces, the total clockwise moment will be equal to the total anti-clockwise moment. So let's look at this illustration. Let's look at a uniform beam pivoted at the center of gravity. Then let's have a force here acting down there. When we place a load here, the object no longer be stable. Let's call the object AB. You're going to move toward the direction. And to restore equilibrium, we have to put another force on this side and adjust it. They call that force F2, that mass F2. Adjust it along this axis until the body comes up again. Now let the distance between this is the point of pivot, between this and that be equal to y. Then the distance between F2 and that is equal to z. So if the body is meant to rotate in this direction, which is the direction? About the pivot. So if A goes down, then B will go up. So look at this system pivoted at B. There are two forces, F1 and F2, on either side of the pivot. The distance between F1 and B is y, between F2 and B is z. So let's assume that this end of A is moving in the direction. So if A goes in the direction, B will now go in the upward direction. So we can call this movement clockwise and call this other movement anti-clockwise. Movement about the pivot. So clockwise moment now will now become, since moment is force times regular distance, now become F1 times y. Y anti-clockwise moment will now become the force on the other side multiplied by the regular distance for the pivot, which is F2 times z. So for this body to be at equilibrium, not moving to any side, it means that F1 times y, which is a clockwise moment, will be equal to F2 times z, which is the anti-clockwise moment. So That's the principle of moment. For a body to be at equilibrium on the direction of a system of forces, then the total clockwise moment must be equal to the total anti-clockwise moment. So for this object to remain steady, not moving, not accelerating or remaining steady, it means that the product of the force acting on this side of pivot and the distance measured to the pivot must be equal to the force, product of the force acting on the other side measured to the multiplied by the distance measured to the pivot. So that's the principle of moment explained on the board. So next, we're going to what is meant by the center of gravity. C of G, or what we call G, center of gravity. So in moment, or in mechanism, the center of gravity is the point on a body where the weight is concentrated. The point on the body where the weight is concentrated is called the center of gravity. In mechanism, the center of gravity depends on the kind of body we are dealing with. For uniform body, the center of gravity is at the midpoint. That means at the center of the body. So the object is a uniform body, the center of gravity will now act at the midpoint. Examples include a uniformity rule. Uniformity rule has its center of gravity at the 50 cm mark. Because we know in physics, a meter rule has the length of 100 cm. The midpoint will be 50 cm. But the meter rule is not uniform. If it's not uniform, center of gravity cannot be at the 50 cm mark. You have to determine by experiment. Another example, a uniform rod of length 150 cm would have its center of gravity at the 75 cm mark, which is half the midpoint. Then a square or rectangular object, we have its center of gravity at the point of intersection of the diagonals. So for instance, let this represent rectangular object. The diagonals will intersect at the center. That point where the diagonals intersect becomes the center of gravity. Likewise, a sphere object. The same thing applies also for a rectangular object. Center of gravity will lie at the point of intersection of the diagonals. For a circular object, the center of gravity will be at the midpoint, at the center of the circle. But if the object is not a uniform body, the center of gravity has to be determined by experiment. So it will no longer be at the midpoint. So these are important points we should note when we are talking about mechanisms or calculations in moment. Now, having understood this, or this concept of moment, then we should know how to solve problems involving the single variable system, or steps to solve problems involving single pivot or pivot. So what are the steps we take? We want to solve problems on moment involving a single pivot system. The first we have to do is, one, we sketch a horizontal line representing the body. You sketch a line with the body. The second one is locate the center of gravity of the body and position the mass or weight of the body at this point. Number three, locate the balance point or point of pivot and position the knife edge or pivot at this point. Then the third point is locate the position of the respective forces or masses hanging on the body. Number five, find the perpendicular distance between each force or mass. So these are the steps to take. I want to make a calculation of a single how to learn or know how to get a ball diagram. I said, sketch the horizontal line. Let's say the body is a meter rule. I'll sketch a line, horizontal line, present the uniform body. Perhaps, let me call this end A, call this end B. If it's a meter rule, the end A is the 0 cm mark, while the end B is the 100 cm mark. That's the first step we take. Then number two says locate the center of gravity of the body. Now, if it's a meter rule, which is 100 cm, uniform body, the center of gravity will be at the 50 cm. So this could be 50 with the center of gravity. But if it's a uniform rod of 120 cm, then my C of G will be at 60. So when you find the center of gravity, you now draw an arrow. At this point, you write the weight of the body or the mass of the object under it. Then the third says locate the balance point. There should be a balance point in the question. Let's say it balance at the 30 cm mark. You place the knife edge, a triangular shape, the knife edge, at the balance point. Let's assume that is the 30 cm. That's where you have the balance point. And then you locate the balance point and position the knife edge. Then number 4 says, locate the position of the respective forces hanging on the body. So depending on what happened in the question, maybe you are told that you have a force of 10 Newton at the 10 cm mark. So 10 cm will be before 30. So this should be on at this side. Maybe a force of 10 Newton at the 10 cm mark. So 10 Newton at 10 cm mark. Perhaps you also told that you have a force of, let's say, 30 Newton at the 70 cm mark. This is 10 cm, 30, 50. So to be at this point a force of 30 Newton at the 70 cm mark. By so doing, you are now positioning the masses or the forces. The next thing is you find the distance between each force or mass and the pivot. So this is the pivot. You have to find the distance between each force and the pivot. So from this is 10, here is 30. The distance from 10 to 30 is 20. That is 30 minus 20. Distance between the weight and because the weight is the force. The weight and the pivot is also the same to it, which is 50 minus 30. Distance between the 30 Newton and the pivot is 70 minus 30, which is 40. So you find the distance between each weight and the pivot. Each weight and the pivot. So all distances must measure to the pivot before you do your calculation. So these are the steps involved when you want to tackle problems on the single pivot system. I'll try to look at problems on moment. Let's look at this first question. It says uniform meter rule is pivoted at the 30 cm mark. If the rule is kept in equilibrium by a force of 50 Newton hanging at the 18 cm mark, calculate the mass of the rule. So I gave you steps for solving problems on meter rule. The first you have to do is to sketch the horizontal line, present the meter rule, or the body. In this case, the body is a uniform meter rule. Can label it AB, whatever you want to call it, or SY, not mandatory. We'll know that this is the 0 end and this is the 100 cm end of the meter rule. Then I told you the next thing you have to do is to find the center of gravity. See the uniform body. Center of gravity of this meter rule should be at the 50. That is half of 100. That is 50. That is where you have the center of gravity. And I say at that point you have to put the mass of the meter rule or the weight of the meter rule. So, or the weight of the body, but in this case it is the meter rule. Go to the question again and find the weight of the body. It says the uniform meter rule is pivoted at the 30 cm mark. If the rule is kept in equilibrium by a force of 50 Newton hanging at the 18 cm mark, calculate the mass of the meter. So we don't know the mass is what we're looking for. We look for the weight of the meter rule. So let's call here W. The weight is unknown to us. Then after that, I said the next thing we have to do is to find the pivot. Where is the balance point? Where would you place the triangle? Say the uniform meter is pivoted, that the balance at 30 cm. So the pivot is at the 30 cm. We come back to the diagram. 30 is before 50. Locate somewhere here as 30 and put your pivot. Then that is where you have your pivot. When you have done that, they say the next step I gave you is you have to handle the other forces. Go to the question and find out the other forces that are on the meter rule. You say if the rule is kept in equilibrium by a force of 50 Newton, is a force hanging at the 18 cm mark. To have a force of 50 hang on the 18 cm mark, we'll go to the diagram. 18 cm will be before 30. Let's call here 18. And at this point, at the force of 50 Newton hanging on the 18 cm mark. We are now out to find the mass of the meter rule. What then do we do? The first step or fifth step I gave in that procedure is you should find the distance between each force and the pivot. The distance between this force and the perimeter distance, of course, is 50 minus 30, which is 20 here. Distance between this force and the pivot is 30 minus 80, which is 12. You now take a moment. Let's assume that the meter rule is moving in this direction. This one will be going up. We take this side as clockwise, take this place as anti-clockwise. So our clockwise moment will now become the force acting down there, that is 50, multiplied by the distance measured to the pivot, which is 12. So that gives us 600 Newton centimeter. Remember this was not converted, this is CCM, this is in Newton. Then the anti-clockwise moment will now become equal to the force acting on the other direction, that is W, that is the weight, times the vertical, which is 20. So Newton cm. Now, obeying the principle of moment that says that clockwise moment equal to anti-clockwise moment. When I say clockwise moment is equal to anti-clockwise moment. So the clockwise moment from our calculation is 600, while the anti-clockwise moment is 20W. You make W the subject. W now becomes 600 over 20, and that gives us 30 Newton as our weight. But this question, we are asked to find the mass of the meter, not the weight. The question is on mass. We have to find weight because the force here is expressed in Newton, so this one should be in Newton also. We have to find the mass. You know in physics that weight is mass times acceleration due to gravity. So mass now becomes weight all over acceleration of gravity, which is 30 over 10. So if you divide, we'll have 3 kg as the mass of the meter. We want to convert to grams, you divide by 1,000, you now have the value in grams. So you look at our work and then observe what we have done and the steps we have taken to solve this problem. So now go to number 2 question over there. That says a uniform meter rule of mass 90 grams is pivoted at the 40 cm mark. If the rule is in equilibrium, when our unknown mass is placed at the 10 cm mark and the 72 gram mass at the 70 cm mark, I mean the unknown mass. For us to solve this number 2, we still have to sketch, for the procedure distance, sketch the horizontal line, present the meter rule. So, and being a meter rule, we know that the length is of course 100 cm, 0 to 100. So, the next thing we do is to find the center of gravity, which is at the 50 cm, that half of the rule, 50 cm mark. If it's a rod of 120 or 120 for instance, uniform body, the center will be at 60. If it's a rod of 150 cm uniform body, the center will not be at 50, at 75, sorry. Then at this point where you have the center is where you locate your mass of the meter rule or the weight. We go back to the question and find the mass, whether they gave us the mass. The first sentence says that uniform meter rule of mass 90 grams. So unlike the previous question, we have the mass here. The mass of the meter rule is 90 grams, put mass 90 grams under the center of gravity. It's pivoted at the 40 cm mark. Pivoted is, where is pivoted the balance point? 40 cm will be before 50. Where you place your knife edge, the balance point. Okay, let's go back to the question. And then we'll now look for other masses. If the rule is in equilibrium, when our unknown mass is placed at the 10 cm mark, we go to the diagram. The unknown mass at the 10 cm, 10 will be closer to 0. So our unknown mass, we don't know the mass. This place, let it be 10. Unknown mass, the mass will m at the 10 cm mark. And let's go back. Unknown mass at the 10 cm, play at the 10, and 72 gram mass at the 70 cm. So 2 gram mass at 70 cm. So let's locate 70 on the diagram here. 70 will be after 50. And then here be 70, then 72 gram mass is here. We are now asked to find the unknown mass. To make sure that you have a proper force diagram for it. So when we have located everything, all the masses put in place, we now find a distance between each mass or each force and the people. So this is 10, where is 40. The distance there is 30, that is 40 minus 10 minus 30. So this place is 50, 40. This one here is 10, that is 50 minus 40, that gives us 10. 70 equal to 40. That is 70 minus 40 giving us 30. Let's rotate the data rule in this direction. So the force is before the pivot here because clockwise and there's only one force here on mass here. Where the mass is opposite the other pivot goes anti-clockwise. So clockwise moment will now become the force acting down here, which is the mass, times 30, the distance to the pivot, which is 30 m. Then anti-clockwise moment go to the other side of the pivot. We now have the first is the mass of the meter 90. Distance is 10. 90 times 10 plus which other mass you have 72 to the pivot, which is 72 times 30. 72 gram. Distance to the pivot is 30. That gives us 900 plus. Multiply this, we're going to have 0, 6, 2, 1, 2, 1, 0, 6, and then 21. So when we add these two together, we're going to have this calculator 900 plus 2160. Have 360. So use the principle of moment, which says that clockwise moment equal to anti-clockwise. We now say clockwise 30 m equal to 3060. Make m the solid m that becomes 3060 over 30. That gives you 102. That's how being gram because the masses are written in grams. So the unknown mass is 1 gram, 2 grams. That's the way equation. So let's look at our working and see how the work was done and how neat it is. So go to the third question. The third question says presents a uniform rod. AB presents a uniform rod of length 1.50 meters, the uniform rod, which is in equilibrium on a pivot at P. That's a pivot at P. If AP, that is from A to P, is 40 cm, find the mass of the rod. So look at this question. The length of the rod is 1.50 meters, which is taken as 1.5 times 100, 150 centimeters. The center of gravity of the rod will be 150 over 2, since the uniform rod is 75 cm. So we have to convert to cm, even though it's not a standard unit, so that we can have a value that is big, large enough. So we go back to the diagram. A is here, 7 Newton. Then B is there, and then B is here. Distance from A to B is 40 cm. Or this should be the 0 end. So this is 40. And then the center of gravity is at 75 cm. This position is here, 75. This is where the center of gravity is supposed to be. And what should be here is the mass of the rod. And we're asking for the mass of the rod. Go to the equation. We ask for the mass of the rod. So, what else do we need? They say, okay, the diagram is not complete because it's not complete as I say it here. So, we have to make it complete based on the information provided. We now find the distance between each. There we have two forces here, this and that, between each force and the pivot. So since this force is in Newton, what we have to find first is the weight of the rod. Then after can convert it to mass. So from here to there is already 40. From here to there should be 35. That is 75 minus. The value here should be 40 because this is 0 end.
So if here is 40, this is, that means this point is 40. 40 minus 0 will give you 40. So then 5 minus 40 gives us 35. So we'll take this place as clockwise. Clockwise moment become 7 times 40, that is 280 Newton centimeter. Then anti-clockwise moment will now become 35 W, that is W times 35. Equating moments, so when I say clockwise is equal to anti-clockwise, that is 35 W equal to 280. So W now becomes 280 over 35. If you divide this, we're going to have 8 Newton as our weight. But the answer says, the question says find the mass, not the weight. So okay, the answer should be in Newton because this one is written in Newton. The question gives this in Newton. So we'll find the mass. Weight is mg. Mass becomes equal to weight over g, which is 8 over 10. Since the value of g is 10, giving us 0.8 kilogram. So having done that, we're going to take one more problem of moment of a force as we look at our working. Look at this problem. Uniform rod AB of length. The length of this rod is 40 cm. So the center of gravity will be here at the 20. And with the weight of the rod given to us as, let's say, for example, the weight is 80 Newton. So I have a uniform rod. The diagram. So we can say AB is a rod, uniform rod of length 40 cm and weight 80 Newton. It's a pivoted at the 25 cm mark and held at equilibrium, kept at equilibrium by a string at one end. Find the tension on the string. So look at the question again. Now this is a rod AB of length 40 cm, that the full length is 40 cm, and then for the diagram the weight we add at the center of gravity, which is 40, half of 40 is 20, which is here. The weight is 80 Newton. We pivoted at the 25 cm mark, and we asked, it's also kept at the string, have a string here at the end. We are now asked to find the tension on the string. So how do we resolve this problem? To solve this problem is not difficult. We have the string, we have to sketch it. So this is the center of gravity at 80 Newton, but the length is 40 cm. So the C of G will be at the middle, since the uniform body gives us 20 cm. Here, they'll have the pivot. The pivot is at 25 cm. They'll have a string down there, and that is making an angle of 30 degrees with the rod or with the horizontal. We're looking for the tension. So how do we solve this problem? So
So all we have to do is we find a distance. Then we're going to create an imaginary force here. A force that's going to be perpendicular or that will be at 90 degrees to the wood. So they're going to create an imaginary force that's going to be perpendicular or at 90 degrees to the wood. They'll find a distance as we use as in the other former example, the distance between each force, each particular force and the pivot. So since the length is 40 cm, here 25, so this will be 40 to the end. 40 minus 5 giving us 15 here. And then from here to here is 25 minus 20 giving us 5. So the distance between each force and the pivot, you have to find it. We create an imaginary force because the strain is not perpendicular to the wood. So when you have done that, we now find the force F. Taking moment here, take it as clockwise. 5 times 80, taking place as clockwise moment, equal to F times 15, taking place as anti-clockwise. So now 400 equal to 15F. F now becomes 400 over 15. So dividing 400 by 15, we're going to have 400 by 15. We have 26.7 Newton. So the imaginary force over there is 26.7 Newton. But we're not looking for this force, we're looking for the tension that exists on that string. If you complete that shape into a triangle, the angle here is also 30 by virtue of alternate angles. So let's draw the triangle out. We'll have it again here. Here is 30. The force here is 26.7, which is the F calculated here. We're looking for the tension. The angle here is 90 degrees. So this is the opposite of this side, and this is the hypotenuse. Opposite side is the angle, and the longest side is hypotenuse. Now say sine. Sine 30 is what opposite over hypotenuse. You make t the subject, t now becomes 26.7 over sine 30. We have 26.7 all over 0.5. And that will give us 53.4 Newton at the tension on the string. So you can see our working on the board and then understand the concept of moment of a force. So in the next video, we're going to look at the complicated cases in moments that involve double pivot system, and also the one that involves tension on strings, mainly for those in their final years and secondary school, and also for those doing general physics in first year of their higher institution. So remain connected and continue